I present to you two questions to try. And I'll just make it P1 and P2, make it bold. So can you read those two questions and see if you can come up with an answer? What are the two numbers for each of them? Off you go, off you go. You think you start with me yapping? No, no, no. You stop, think. Make sure you have your date, title, everything in your book all set up, and you try those two. You two, though. Yeah, yeah. Good, 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 good. Now, so you've done it. You got two answers. What did you did? First one. What did he come up with? You're thinking, Well, first things I'll deal with, just to be absolutely clear. Sum. When we talk about the sum, it's the answer you get when you add the numbers. So that means I got two numbers, and when I add these two numbers, I'm going to get 15. And then when we talk about the word product, it's the answer you get after you multiply two numbers. So there's two numbers. Well, when I multiply them, I have to get 50. And quickly I start, what comes to your mind? Is it the same thing that came to my mind? I'm thinking 10 and... You seeing it? Yeah, 10 and 5. Because, and you got to check, 10 plus 5, well, that'll give you 15. And 10 multiplied by 5, that will give you 50. Ooh, yeah. How about the second one? How did you get on with the second one? Or if you haven't done the second one, let's just say, so what, you weren't sure about the wording. Now you know what product is. Now you know what the sum of two numbers is. Try number 2 if you haven't already. You still have a chance to use the power of the pause and try the question. Yeah, my turn. Product to two numbers is minus 14. The sum of the numbers is 5. Wow, this one a bit tricky. Negative number, negative 14. Wow. Your strategy. Write down pairs of numbers that will give you 14. Just don't forget the negative for a moment. Just think about pairs of numbers that are going to give you 14. You're gone. Write down all the pairs of numbers that when you multiply them, you can get 14. Pairs of numbers that have a product of 14. Another one where we're saying it, factors, right? Factor pairs of 14. Factor pairs of 14. And yeah, you got it? Pause if you need more time to think about it. 1 and 14. That could work. 1 times 14 will give me 14. Is there another way? Are there other ways you can get 14? Yeah, 2 and 7. 2 times 7 will give you 14. Now we got to start thinking, well, hang on, it was negative 14 we were supposed to get. We're supposed to be minus 14. And when we add the numbers, remember, when we add the numbers, we're supposed to get 5. So now let's start thinking about negative 14. And what you want to think about, which pair of these numbers have a difference of 5? Because we want to get 5. Which one? And 1 and 14, that's just a goner. Because 1 is nowhere near 14. It's not, the difference is not 5. You're not going to get 5 from a negative 14 and a 1 or a negative 1 and 14. And I started talking about negative y because the only way you'll get minus 14 is if one of these numbers is actually negative. One of the numbers has to be negative. And now you have to be thinking, well, which number has to be negative if when I add it up, I'm going to get 5? You feeling what I'm feeling? I'm going to go with minus 2. 7 plus minus 2, or minus 2 plus 7, that is going to give you 5. So your two numbers, minus 2 and 7. How do you feel about that? That makes sense to you? You're feeling that? If you feel that, then we're off to a fantastic start. Let's build on this idea. Now I'm going to ask you to go back in time, and hopefully go just as back as what we just did. That's my little hint. But also remember, we did factorize in quadratics, did we not? So this is revision from stuff we did. I don't know which, I can't remember the task number, but go back in the video library, the task, or go back through your book. You should see factorize in quadratics. It's there. We did this. So factorize those two quadratics, please. And hopefully now you see the link between what we did in part 1 at the start of the lesson, part P1 and P2. Right. Well, right. You remember it. Pause. You done. If you need more time, you pause. If you need, you pause. Pause. Work on it. Work on it. I want you to factorize those two expressions. Let me start giving you hints. What do I mean by factorizing it? We mean that you're going to write it in double brackets. You know it's a quadratic. It has an x squared term. We're going to think double brackets because the only way we can get that x squared term is if we do x multiplied by x. So we're just going to put that in terms of factorizing. We're going to have x multiplied by x. And now you're thinking, you remember this? It's back to mind. If you didn't do it, do you remember it now? Yeah. You want to finish the job? What's the question you always ask yourself? Factorize quadratics. You should be asking yourself, what two numbers? Yeah, you see the link to P1 and P2 now? What two numbers, when you multiply them, you get 50. When you add them, you get 15. Multiply to get 50, add them to get 15. That was the same question you asked at the start, and it was 5 and 10. If you were to expand these double brackets, remember, factorizing is the opposite of expanding. If you were to expand and simplify these double brackets, you would get x squared plus 50 and x plus 50. Yeah. And then on the basis of this, what's the missing numbers here? What's the question you ask to factorize a quadratic? You ask the same questions every time. What two numbers, when I multiply them, I got to get minus 14 when I multiply them in this case, and when I add them, I have to get 5. You'll go through the process we already went through for P2, and you're going to put your minus 2, and you're going to put your positive 7. Oh, yeah. You feeling good? You remember this is coming back to you. If you need to go back and do more practice on the factorizing exercise, you go back. But we did it. We did it. You should be able to do this. Now for the big moment. This was just a jog in memory. Now we're going to extend what we did so far, what we did in the past with factorization. Boom. I'm not asking you to factorize anything. The question now is to solve these equations. But do they look familiar? Did we not? You see that? Yeah, and look, what's the title? What's the learning objective? To be able to bad is to be able to, just in case you forgot, to be able to solve quadratic expressions by factorization. You got a hint? You think you know what you need to do first? Exactly. The first thing you do, you get an equation like this to solve, try to factorize the expression. I say try because it won't always factorize. But there's other methods we can learn later on. Right now, we're dealing with things that can't factorize, but I have to say try. And can you write it in double brackets? Yeah, we already did this factorization. We're going to set up the double brackets. We're going to put the x, and we know it's plus 5, and x plus 10 is equal to 0. Now, where do we go from there? After you've factorized the expression, the quadratic expression, you have it equals to 0, must be equal to 0 on the right-hand side. Keep that in mind. That will pay big dividends later on. Has to be equal to 0 on the right-hand side. What do you do? What do you do? You need to solve. Remember, solving is finding the value of x. Finding the value of the unknown. That's what we mean by the word solve. So we need to know, well, what is x going to be? What can you multiply by to get 0? If I had 2 times some number equals 0, what would the number be? And if I had some number times 5 equals 0, what's the missing number? What does it have to be? You with me? The only thing it could be is 0. Only 0 times another number is going to give you 0. You have to multiply by 0. What does that mean? It means to solve this equation, to finish the job, after you factorize, it's either the first bracket, x plus 5, is going to be equal to 0, or, and let me just set this up a little bit different actually for space, or the second bracket, x plus 10, is going to be equal to 0. That's the only way you're going to get 0. One of those brackets have to be 0. And that's the thing about quadratics. You could have, not always, but you could have two different values. If x plus 5 is equal to 0, how is that going to be? Well, x has to be equal to minus 5. What times 5? What plus 5? What am I saying? What plus 5 gives you 0? Minus 5. Minus 5 plus 5 is 0. And then similarly, the other answer could be x minus 10. X is equal to minus 10 because minus 10 plus 10 will give you 0. That's how you solve a quadratic equation. You one method. You factorize if you can, and then you set each bracket equal to 0, and you will get the solutions. It could be two solutions. Sometimes the solutions will be the same. That could happen. And what do? You just did this because your teacher did it, showed you it, and you move on? No, you check. You use substitution, and you check your answer. So let's do a quick check. Minus 5. We want to do minus 5 squared plus 15 times minus 5 plus 50. And we want to see what we will get. And plug it in a calculator. Because numbers like this, most likely a calculator paper, I'll probably say. I'll just work it out. I got my little calculator here. Mini one, not that big. But the minus 5 squared is 25. It's positive 25. A minus times a minus is a plus. 15 times. So what you're getting here, let me just put it in, is you're getting 25. Then you're getting take away 75. 15 times minus 5 is a minus 75. And then you're getting adding 50. And that will give you 0. Because 25 and 50 is 75. And 75 take away 75 is 0. And it's like, yeah, you did it. Let's use the model and do the next one. Yeah. Finish the job. Do the next one. You know how to factorize that. We did it already. So you just got the last step. What's the last step again? The only way you can get 0 is if you multiply by 0. So each bracket has to be 0. That's what you want there. Sort it out. You done? Oh, come on. Sorry, I'm being too quick. Pause. You done? Yeah, now it should work because you paused the video and then you did it. And then you you freed me. I'm free. I'm like the genie out of the lamp now, and I can actually do some maths. Yeah, right. So you got the equation to solve. Let's just run through the whole thing. You're gonna try and factorize it. Trying to factorize means you're asking yourself, what two numbers, when I multiply, I get minus 14. I have to multiply to get minus 14. I have to add to get 5. So that's the process you're running through. You're trying to factorize. We've done factorizing before. And you write it in double brackets. You ask yourself those questions and you get the numbers. The numbers in this case is going to be x. We know we're going to have the x's. And the numbers we're going to have, two numbers. I multiply to get minus 14. I add to get 5. It's going to be positive 7 and minus 2. Because 7 2s are 14. The sign's a difference, so I'll get the negative 14. When I add it, 7 plus minus 2, or minus 2 plus 7, that's positive 5. That's the process. Now that I know my numbers, I set each bracket to be 0. That's the only way I'm going to get 0 when I multiply the brackets. It's either x take away 2 equals 0, in which case x is equal to 2. Because 2 take away 2 is 0. Or x plus 7 equals 0, in which case x is equal to minus 7. Because minus 7 plus 7 will give you 0. That's what we're talking about. There. That's how you solve quadratics by factorization. When we have the number in front of x squared when it's 1. And that's the case we want to look at. The only thing left here is for you to practice and drill. And remember, it's an additional step after you factorize. It's equal to 0, must be equal to 0. So make sure you have that set up. Then set each bracket equals to 0. If you think, and here you go. Whole exercise to do. 10, that's what? 5, 10 of them. You need, this is such a, again, just like simultaneous equations, this is another one of those big, super important topics in maths that cut across everything right up to advanced level maths. So you got to be able to do this. Practice and drill is super important. If it is you cannot remember the factorization, or if you think you need more practice or more detail from me in the factorization, then go back to the video on factorization. Look back at it. Task 20. Task 20 is the number. I just checked it. Task 20 has more factorizing quadratics if you want to practice factorizing before you solve these equations if you think you need more practice. But off you go, factorize and use the factorization to solve. And the answers, I'm going to put up the answers for you now. Here you go. These are the answers you should have had. The two values of x for each. Two values of x for each. Okay, you have a chance. Mark your work. Pause and mark your work. Now let's move on. We're now going to look at some different types of quadratics when it's not that set up the double bracket situation, and then let's just work through. And I invite you, just experiment and see what you can come up with. You have to do these a bit differently. They're not as the ones before. Some people say they're easier, but you just got to spot how to manage them. So off you go. You go. Right. So I'll show you what I'll do here. Now, if you decided, some people, I think here, what they might look at is divide by x, and then you get x is equal to 11. That's a nice strategy, but it means you end up missing a solution. So you never do this. You never do this. Okay? This is a no-no. That is wrong. You see, the thing is, and it has to do, you see, the situation is because of that x squared. You got to remember that when you square a number, or if you think the opposite of squaring a number is square rooting. But let's say it was 16. If I ask you, what's the square root of 16? What's the square root of 16? You're thinking 4? That's one of the answers. It's positive 4 or minus 4. Because a minus times a minus is a plus. Yeah, so there's two solutions, and as a result of that, when you divide by x, or if you want to think about square rooting both sides, that gets messy if you wanted to go down that pathway. That's not going to work. But if you divide by x, you end up losing a solution. Okay, hopefully that makes sense. What you need to do in a situation like this to prevent yourself from missing a solution is to set the quadratic equals to 0. And you want to always do that. Set up a quadratic. Once you have that x squared term, you want to set up the equation so that the left-hand side is equal to 0 on the right-hand side, or vice versa, 0 on the right, and the expression on the, no, I'm saying the same thing, 0 on the left. So you either want x squared blah 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 equals 0, or 0 blah 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 equals x squared, or x blah blah is equal to, oh my goodness, what am I doing? You know, I'm not gonna, oh my goodness, x squared blah 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 equals 0, or 0 equals x squared blah 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 blah. That's what I mean. You want to shift everything to one side equals 0. That's the technique you want to use. Hopefully that makes sense as well. Better if I just make the example. I'm going to leave my x squared, but that 11x, I'm going to take it onto the other side and make it minus 11x. And then I'll put it equals to 0. That's what I'm talking about. After I've done that, and you'll see that a and b look similar now, I'm going to factorize a. I'm going to factorize because they have x in common, so we want to factorize. No, we're not dividing by x, we're factorizing. The common factor is x. So x, and then in brackets, x take away 11. We've done work on factorizing. Again, if you this one would be task 19, I believe, expressions like this are looked at. So you see what happened there. I've got everything to the left. I've made it x squared minus 11x equals 0. Then I've factorized. And now that principle of what we were doing before, the only way to get a 0 is if each of the expressions, the expression in the bracket or the expression outside the bracket, is a 0, which means that x has to be either be 0 or x is equal to 11. The x equals 0, that solution was missing with the original approach. That's the bit we needed to capture. And you need to have that as a solution or you will not get full credit. So keep that in mind. Get every quadratic you want it set up where it's equal to 0, then you get your solutions. Okay? Or you'll run the risk of missing a solution. For B, it's already left-hand side is already equal to the right-hand side 0. So I'll factorize. The common factor is x. X, and I put x plus 15 in bracket is equal to 0. So just like A, it means that the value, it's either x is equal to 0 or x in this case is minus 15, because minus 15 plus 15 will give me 0. C is a bit trickier. C is a bit trickier. Okay. To factorize C, or I'm going to do this two different ways, and I'm going to actually contradict what I did before, but I'll explain to you why. What's the difference between A, B, and C? I'll ask you that. The difference is, in the case of C, you don't have an x term. It's just a number by itself. I have x squared take away 100. Okay. Now, you can leave it like this, and you have to factorize. And the factorization is this idea of the difference of two squares. Do you remember that? Again, all of that is in the factorization video, so probably we're looking at video task 23 maybe. But x squared minus 100x, minus 100, it's not 100x. If I factorize that, it's going to be x plus 10, x minus 10 is going to be equal to 0. And then from that, if I put that as my solution, you can quickly tell me that x is either going to be 10 or x is going to be equal to minus 10. So if you remember the difference of two squares, that's your solution there. Factorize and get you two solutions. Each bracket has to be equal to 0. But, if you don't recall that, in this case, because it's a number, we can break that rule about having 0 on one side, and you can actually set it up as x squared is equal to 100. Minus 100 on the left becomes 100 on the right. Why? Because now you can square root each side, and that becomes x is equal to plus or minus 10. Same answers as before. And we can do that because we have a number, and when we square root it, we can square root the number. We couldn't do it for A because of that letter. Square rooting the x, that's where it was going all funny there. But we can do it for C with the number. These are easier, but in some ways harder. Study what I've said so far. Hopefully it makes sense. Hopefully you feel comfortable with it. If not, just pop a message, a comment, or get in touch so I know, and I'll consider looking at it differently. I'm going to give you some questions to work on. And all these questions have some interesting quirks. The key thing you need to remember is what I described in these examples. And those big ideas that make sure all the terms are on the left-hand side are equal to 0. So you might have some rearranging to do, except in the case where you might want to deviate from that rule where you just have x squared and a number. So here are the questions, and remember, before you can solve these, all the terms need to be on the left-hand side to be equal to 0, or in the case of a number only, you might want to, so G and H, you might want to do it slightly differently using the difference of two squares. So I've given you a hint, some sense of how you could work through these. Off you go. See what you come up with for these. Right. Now, so you had your pause and you're working through it. You've probably finished the exercise now, or you've worked through some of it, or you probably think it's too difficult. I just want to give a couple hints and give you a chance if you haven't put the answers, or give you a sense of what the working should have been. You needed to rearrange. I'll do G and H. I would have considered these as x squared is equal to 9. Then you're solving that, and then x squared is equal to 49. That's what H is. I move the minus 49 onto the other side, becomes positive. Minus 9 on the other side becomes positive. For A, it's x squared plus 8x is equal to 0 is what you're working on. For B, 3x squared plus 4x is equal to 0. So moving everything to the same side. For B, that means you're going to get a fraction. That's my hint to you as well. You're going to get fraction. For C, you have x squared plus 5x plus 50 equals 0. So you've moved everything to the left and it's equal to 0. So that's when you have to solve using the double bracket technique we learned initially. Then for D, it's x squared plus, actually it's not plus, what you'll do, you should end up with minus 17x plus 70 is equal to 0. What I've done, the 17x is positive on the right, so it becomes negative on the left. And I've kept that convention of having x squared, then the x term, then the number by itself. So that's what that looks like there. E, it's x squared plus x plus 56 is equal to 0 when you rearrange and then you solve. So set up the quadratic as equal to 0, then solve it using factorization. F, x squared plus, well, no, not x squared plus, it is, and oh, I made that mistake on E as well. Gotta be careful with it. It is minus 50. Give me a different color now. Minus 56. Minus 56 is equal to 0. Did I do that anywhere else? Yes, I have done it for C. It's the same problem. Gotta be careful with your signs. Change the side. Change the sign. Change the side. Change the sign. So x take away 50 equals 0. Take away 17x, take away 56x squared. It will be take away, let's deal with this one, x squared. Take away 14x. Take away 51 is equal to 0. That's what you're looking at there. So now after you, so you have in questions like this, you must rearrange, get the quadratic equals to 0, except in those special cases of G and H as I've talked about, and then you factorize and solve using the techniques that we've demonstrated. Okay, and the last piece of working I will show on this because it's different. For C, for E, for D, and F, we're doing our normal double bracket strategy because we have an x squared, an x, and a constant term. For A, you would have next written down that x multiplied by x plus 8 is equal to 0. For B, it would be x is a common factor, and then you're multiplying by 3x plus 4. So 3x plus 4 has to be equal to 0. That means 3x has to be equal to minus 4. That's the idea there. So I've gone through a lot. Study that. Use this to build. You have a chance. You can pause. Rearranging, that's an additional step, but you can finish the job now to get solutions. Time for me to give the answers. 5, 4, 3. You worked on it. You've paused. You ready? Let's do this. These are the solutions you should have for these questions. I really hope that made sense, and you're thinking, yeah. This, if it is that, from a foundation perspective, this is end of the exam paper, grade 5 territory. Touching into like the last ones we did, they're more likely to be on a higher paper, touching into grade 6 work there. So very much on the boundaries of higher end foundation, particularly the problems that we just did, practice 7. I would expect that on a higher paper, or very so you get a sense of the difficulty involved, and hopefully you've made some good progress on it, and you're thinking, right, I'm firmly on top of things. Good stuff.